Hi guys, today let's talk about heat calculations. So we're going to be using our heat equation Q equals mc delta T. But before we jump into the problems, let's talk about each of those variables and what their units are. So Q is our variable for heat energy, or just heat itself. And the units of Q, there are two common units. We can either have Q in terms of joules, which is denoted by a capital J, or we can have units of calories, which is denoted by CAL. M is our variable for mass, and the units of mass are grams. Now, C is the variable for specific heat. And the specific heat is different for each and every substance. So this is why each substance absorbs and releases heat in different ways. Now you can help remember your specific heat variable is C if you just remember that the last letter in specific heat is also C. The other way that we can pick out specific heat is by knowing its units. It has a compound unit of either joules per gram degree Celsius or calories per gram degree Celsius. And the reason for that is actually going to be in one of our examples. But because specific heat has this large compound unit, it also makes it pretty easy to pick out from problems. Now, delta T refers to change in temperature. This Greek letter delta here, this triangle, is what we use in science when we want to say change in something. And then, of course, T is temperature. So delta T, change in temperature. Now, to calculate the change in temperature, we always take the final temperature minus the initial temperature. So T final minus T initial. So where did the temperature go to? What was the final temp? Minus what was the initial or the starting temp. And of course, the unit of temperature is degrees Celsius. Now, when we go through and start solving these thermochemistry problems using our heat equation, we can think about following these steps here. So the first thing we want to do is always read through the problem and identify our given variables. So what do we know? Secondly, determine the unknown. What is it that we're solving for? What is the question asking? The third is our mathematical magic. We're going to plug in our values and calculate. And then last but not least, we want to round our final answer to sig figs. Now we go with the smallest number of sig figs from the givens. So we're going to go back to those givens and look at how many sig figs each of them has, and then make sure our final answer matches whoever has the least number of sig figs. And as always, we definitely want to include units in our answer. So let's look at an example. So in this example, we want to know how much heat is released when an 8.4 gram sample of metal is cooled from 19 degrees Celsius to 11 degrees Celsius if the specific heat of the metal is 0.38 joules per gram degree Celsius. Okay. So if I go back and identify my givens, the first given is 8.4 grams. Now, the unit here is grams, and the unit of mass is also grams. So that makes this the mass, 8.4 grams. The second givens are temperatures. They have units of degrees Celsius, so these are my temperatures. And it says we went from 19 to 11. So that means my initial temperature is 19 degrees Celsius, and my final temperature is 11 degrees Celsius. The final thing that I am given is 0.38 joules per gram degree Celsius, and I am told that this is the specific heat. But even if I wasn't, this compound unit would identify it because this is the unit of specific heat, one of the ones. So C here is 0.38 joules per gram degree Celsius. So my question is asking for how much heat is released. So heat is Q. So therefore, in this problem, we are solving for Q. That is our unknown. So now we'll plug in our values to our heat calculation, or heat equation, excuse me. So we are solving for Q, but mass is 8.4 grams. Specific heat is 0.38 joules per gram degree Celsius. And to calculate delta T, we always take the final minus initial temperatures. So the first thing we're going to do is that subtraction. So 11 minus 19. I'm sure you can do that in your head as well, but just in case, I got my calculator here. And it is, of course, negative 8 degrees Celsius. All right. So we're now going to multiply each of these values together. And that should give me my mathematical value of Q. So 8.4 times 0.38 times negative 8. Negative 25.536 mathematically. Now let's take a look at what happens to the units. So when we multiply these, we have grams here, but we also have grams to the right of the slash. And that means that grams cancels out and goes away. And the same thing happens with degrees Celsius. Degrees Celsius is here, and degrees Celsius is to the right of the slash in this compound unit. So that means that it cancels out and goes away as well. So the only unit we are left with is joules, which makes sense because Q does have units of joules. So now we think about the sig figs. So if we come back to our givens, we have 2 sig figs here, 2 sig figs here, 2 here, and also 2 sig figs here because leading zeros at the beginning of a number are not significant. So each of our givens has 2 sig figs, which means our final answer should also have 2 sig figs. So our final answer will be negative 26 joules. So the negative sign means that heat has been released, which was given to us in the problem, so we should have an answer that is negative. Let's look at another example. So here we want to calculate the specific heat of a 9.30 gram metal sample that absorbs 86.0 joules of heat over a 7.21 degrees Celsius temperature change. All right. So we first are given the mass of 9.30 grams. And again, I know it's mass because the unit grams is the unit of mass. The next value is heat, which is Q, 86.0 joules. Now I'm told that this is heat, but even if I wasn't, the fact that the unit is just joules would give it away because Q, or heat, has units of joules. And then I'm given a temperature, but I'm only given one, and I'm told that this is the temperature change. So if I'm only given one temperature, that means that I am given delta T itself. I am given the change. So then delta T has already been calculated for me and is 7.21 degrees Celsius. So our unknown, what we are solving for, is specific heat, which means we are looking for variable C. Now, if you know how to rearrange an equation to solve for a different variable, feel free to do that. That is always going to work. But for this example, I'm going to work it out using the equation in the original setup. Okay, so I've plugged in my values to our equation, and now I'm ready to continue my calculation. So the first thing we're going to do is multiply 9.30 times 7.21. So 9.30 times 7.21, 67.053. Now, if I think about my units here, I multiplied grams and degrees Celsius, and nothing cancels out. So I end up keeping both of those units, grams, degrees Celsius. So now I'm going to divide both sides by this value here because I want to get C by himself. That's what I'm solving for. So 67.053 grams degrees Celsius divided from both sides. So this goes away and we'll do this division here. So 86.0 divided by 67.053. 1.2826. Lots of decimal places there. And then look at our units. Joules on the top, grams degrees Celsius on the bottom. Nothing cancels, so we keep all of them. And this is why specific heat has this compound unit, because when you calculate for it, all of the units are still present at the end of the calculation. So now let's look at sig figs. 9.30, that 0 is significant because trailing zeros are significant when there's the decimal. So we have 3 sig figs here, 3 sig figs here for the same reason that trailing 0 is significant because of the decimal, and 3 sig figs here as well. Looks like our final answer should also have 3 sig figs. So we will round our final answer to 1.28 joules per gram degree Celsius. That is the specific heat of our metal. Let's look at one more example together. Here we want to find the mass of aluminum if the specific heat of aluminum is 0.21, oops, that should say calories per gram degree Celsius. Typo. 0.21 calories per gram degree Celsius, and 185 calories of heat was added to raise the temperature from 22.0 degrees Celsius to 28.0 degrees Celsius. All right. So the first given is the specific heat, 0.214 calories per gram degree Celsius. The next given is the heat itself, so that's Q. And in this question, we're using the other common units of specific heat and heat energy. But nothing changes no matter what the units are. The last givens are our temperatures. We go from 22.0 to 28.0. So T initial is 22.0 degrees Celsius, and T final is 28.0 degrees Celsius. Our unknown is mass. So we need to calculate the mass. So we're solving for M. And again, if you can rearrange an equation to solve for a different variable before plugging in, feel free. I'll work this one straight through. So delta T final minus initial, so 28.0 minus 22.0, and that is all of my values plugged in. So this subtraction I will do first, which I'm sure you can do in your head, but to verify, that is, of course, 6.0 degrees. So then we'll multiply these guys together. And when I do that, degrees Celsius is going to cancel out as a unit. So, oops, 0.214 times 6.0, 1.284. And since degrees Celsius has canceled out, the only units left here are calories per gram. So at this point, we will divide both sides by 1.284 calories per gram. So 185 divided by 1.284. 144.081. Lots of decimal places there. When I do this division, calories as a unit goes away because we have calories up here and calories down there. So the only unit left is grams, which does make sense because we are solving for mass. So the unit should be grams. So then let's think about sig figs. Coming back to our givens, we have 3 sig figs here because, again, leading zeros, not significant. 3 sig figs here, 3 here, and 3 here because trailing zeros are significant when there's a decimal point, excuse me. So it looks like we need 3 sig figs. That makes our final answer 144 grams. So when you solve these problems, if you make your list of givens and then you do your calculations on both the numbers and the units, you should come down to the correct answer for whatever it is that you are solving for. But do make sure you go back and find out how many sig figs you should have, because you should match the smallest number of sig figs. Hope that helped. See you later.